Day 653 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1967, number of strings that appear as substrings in Word. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And don't forget to check out that link in the description if you need any new Apple AirPods. Now let's get into the question. And before we get into the question though, y'all, I'm gonna try and do about a month of easy strings. So if you want to get some practice or catch up on your easy strings, go ahead and look in the playlist or the course that's connected to my channel titled Easy Strings, and we can do those together. Now let's see what the question says. It says, given an array of strings, patterns, and a string word, return the number of strings in patterns that exist as a substring in Word. A substring is a contiguous sequence of characters within a string. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input patterns equals an array of strings A, ABC, BC, and D. Word equals a string ABC. The output is 3. So what we want to do is we want to return the number of strings and patterns that exist as a substring in Word. So we want to find these, we want to see if any of these strings exist as a substring in this string. And as we can see, the output is 3. So that means we have 3 different substrings or patterns that exist as a substring in this, right? So let's see what they are. So it could be just A. This counts as this counts as a substring of words, right? Just this. This is a substring A. So A appears as a substring in ABC. Boom. Then we could do ABC. ABC is a substring of ABC. It says ABC appears as a substring of ABC. And we could do BC because BC also appears as a substring of ABC, right? So in total, that's 3. It says D does not appear as a substring in ABC. 3 of the strings and patterns appear as a substring in Word. So this is a substring of Word, this is a substring of Word, and this is a substring of Word. In total, there are 3 strings and patterns that could be a substring of Word, so we return 3. Now, just in case that didn't make sense, let's take a look at example 2. In example 2, our input patterns equals array of strings A, B, C. This time, Word equals a string A, B, 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 B. Boom. This time the output is 2. It says the explanation A appears as a substring in A, B, 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 B. So A is a substring. We already know that because that's just this right here. Boom. Then B is a substring as well, right? Boom, because that's right here. Boom. So that could be a substring. C is not a substring because there are no C's in this string at all. So in total, it's just 2 of these strings from patterns. So we return 2. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, our input pattern equals an array of strings A, and A. 3 different strings. All those strings are only contain the character A. Then Word equals a string AB. This time the output is 3. It says each of the patterns appear as a substring in Word AB. So it's important to realize that even though these are the same characters, they all are their own. They all hold their own count when it comes to counting how many strings and patterns can be a substring in Word, right? So this is its own substring right here, A. This is its own substring right here with this A, and this is its own substring right here with this A, right? So in total, it was 3 strings from pattern that we used that were able to become substrings of Word. So that's why our output is 3. Now, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. And make sure y'all stick around for at the end because I have 2 solutions for y'all today. They're both pretty quick and simple to understand. So I figured why not throw them both in there. Now, first solution, we're going to come right here. We're going to declare a variable called count. We're going to set that equal to 0. And with that's just going to store our output for us, right? We need to keep count for our output somewhere, and that's how we're going to do it. Then we're going to say for pn patterns. So we're going to iterate through patterns. We're going to open up the bracket, right? Because patterns, that's what we're looking for. So we're going to see for P and patterns, we're going to say if word dot contains, open up the parentheses, P, meaning for each one of these, if word contains one of these, then we could just increment count by saying count plus equals 1. Then we could come right here and we could just say return count, y'all. Boom, that's all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted afterwards. Let's see, look at that, y'all. 1 millisecond beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. Now, make sure you get one more look at the code. It's easy to understand. It's pretty self-explanatory. But now let's get into the second solution, y'all. And guess what? We got a one-liner. That's right, y'all. We actually can solve this problem in one line of code. So I figured I might as well add that solution into this problem as well, because why not? So another solution for this, we could just say patterns dot filter. Then we're going to open up the brackets. We're going to say word dot contains, open up the parentheses, $0. Then come outside of that and we can just say dot count, y'all. Boom, that should be all she wrote. Let's give that a run. Let's see. Okay, it's accepted, so let's go ahead and submit it. Let's see, and look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.